Okay, so now we are working on number 2 from that extra practice for the test, these extra practice problems. So for number 2, we do the same steps that we did in number 1, just a different function. We'll even graph it out and everything at the end. Okay, so the total number of zeros, remember, is equal to the degree. So you're going to need to find the degree on this polynomial, which is the biggest power, so 4. 4 is the total number of zeros that we're going to have. And when you have the total number of zeros, or the degree, you also will know the number of terms. You just need to subtract 1 from that. So 3 minus, I'm sorry, I just gave away the answer. 4 minus 1 is going to give you 3. So there are 3 terms that are going to show up on this graph. If you know the degree and the lead coefficient, so it's a positive coefficient and even degree, that means that you know the end behavior. So in this case, if it's an even degree and a positive lead coefficient, it's going to be pointing up on the left and up on the right. So with end behavior, I'm just going to throw this out there. Like, you're going to have 2 directions that you're going to have. What's happening on the left and what's happening on the right. And there's only going to be 2 options for that, up or down. Up on the left, down on the left, up on the right, down on the right. Just a combination of that. So even if you're like guessing, you can just don't leave it blank. Guess. It's up on the left, it's down on the right, something if you don't know what you're doing with that, okay? It's real easy just to kind of get something on that. And remember that end behavior, all it represents is how the graph looks on the far extremes of the graph, on the far left and on the far right. That's what it represents, just like we've gone over in class like a ton of times. Okay, now for the positive real zeros and the negative real zeros, using Descartes' rule of signs. So for the positive real zeros, we check how many times the original function changes sign. So if it goes from positive to positive, that's not a change. From positive to negative, that is a change, so we have 1 there. And then negative to negative is not a change, but from negative to positive it is. So that means that we could have 2 positive real zeros. Or if there's any imaginary solutions, they come in pairs, so I could have potentially 0 positive real zeros. But again, on the test, I really just want to know the maximum number that you could have, so 2 would be perfectly okay for writing down. Next, the negative real zeros. For the negative real zeros, again, we change the sign on the odd exponents. So we have a negative 2x to the third, because x to the third, that's an odd exponent. And then we have an odd exponent again at x to the first, so that'll change to a positive 8x. And then the rest of it just stays the same. So we still have that minus 6x squared, that positive 8, and that positive x to the fourth. Now just do the process again. Check how many times the signs change. So from positive to negative, that's once. Negative to negative, that's not a change. Then from negative to positive, that's a change as well. And then positive to positive, it doesn't change. So that means we could have 2 negative real zeros, or if there are any imaginary negative zeros, then we'd have 0 negative zeros, or negative real zeros, sorry. Okay, so now let's list off the positive number of zeros that we could have. So we use the end value, that constant value, and then the lead coefficient, which again is 1, so it's going to be 8 over 1. We list off all of the factors of those numbers. So the factors of 8 are 1, 2, 4, and 8. The factors of 1 are just, 1. And then we list off all the combinations with this denominator 1. So 1 over 1 is 1, so plus or minus 1. So positive 1 or negative 1 could potentially be zeros in the function. 2 over 1 is 2, so positive or negative 2 could be zeros. 4, so plus or minus 4, and then 8 plus or minus 8. Any of those numbers could potentially be zeros in here. That's when we'd use synthetic division or graphing calculators to find out which ones are the zeros. So in the previous problem, we've rarely used the calculator, but let me show you kind of a shortcut, especially because we have 1, 2, 3, 4, 5, 6, 7, 8 possible zeros to finding your zero values. You can always graph the function out, and then, because there's a relationship between the zeros and the graph. The zeros are the x-intercepts. So if you spot an x-intercept, you can check on your graph to see if you actually do have a 0 there. And then it's just up to you to show the work properly with synthetic division to get to that answer. Okay, so let's graph this function out. So we hit y equals, and then graph it out, x to the 4th power plus 2x to the third power minus 6x squared minus 8x, and then plus 8. So I'm going to make sure that I have all of that correct. So negative 8x, positive 8, negative 6x squared, positive 2x to the third, and x to the fourth. Yeah, we're good. We're good. So graph it out. And on the graph, it looks like, okay, well, I think that it looks like I have a couple of zeros there. Probably one at negative 2, and then probably one over there at 2. Let's go to the table on the graphing calculator. So second table. And yeah, it looks like 2 is a 0, and negative 2 is a 0. Okay? So I can use synthetic division at least to whittle that down or bring it down to a quadratic, because I'm going to have a total of 4 zeros. So let's, kind of work on it from there. All right. So using synthetic division, I'm going to, from my calculator, use 2 and negative 2 in the corner. So 2 in the corner. And then we have 1x to the fourth, 2x to the third, negative 6x squared, negative 8x, and positive 8. So since this is a 0, we are expecting our remainder to be equal to 0. So 1 times 2 is 2, 2 plus 2 is 4, 4 times 2 is 8, 8 minus 6 is 2, 2 times 2 is 4, 4 minus 8 is negative 4, negative 4 times 2 is negative 8, and sure enough we get 0 as a result. So don't just start over again, continue on with your synthetic division using another 0. So I already used 2. Now I'm going to use my other 0 that I see right away, which is negative 2. So negative 2 goes in the corner now. And I do the synthetic division algorithm again. And I should end up, again, with a remainder of 0, since this is an x-intercept. 1 times negative 2 is negative 2. 4 minus 2 is 2. 2 times negative 2 is negative 4. 2 minus 4 is negative 2. Negative 2 times negative 2 is a positive 4. 4 minus 4 is 0. So now this leaves us with this quadratic over here. And I don't know what possible values I could have here, but if they're rational values, then that means that they're going to be, I can actually estimate which ones are going to work. So, I can use possibly some synthetic division in a second here if I have any fractions. But looking back on my possible zeros, shoot, I don't have any fraction values up here. So that tells me that there aren't going to be any other rational zeros, and these ones are probably going to be irrational zeros. Let's see if that's the case. So we've got 3 numbers left, so that means that we've got a quadratic. So this becomes 1x squared plus 2x minus 2. Okay, so what we're going to do now is plug this into the quadratic formula to find our other 2 zeros. And these are going to be estimated values possibly, because I'm not going to be able to factor this. So I'm going to get like an irrational number. So I'm really going to have to kind of like estimate where that value is on my graph when I graph it out. Okay, so let's solve for it using quadratic formula. My a value is equal to 1, my b value is equal to 2, my c value is equal to negative 2. So I plug it in to the formula, the negative of b, so 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is negative 2. And that's all over 2a, so 2 times 1. All right, so simplifying this a little bit, I've got negative 2 plus or minus the square root of, then I've got 2 squared, which is 4. Negative 2 times negative 4 is positive 8, so plus 8. So 4 plus 8 is 12, so 12 goes under the radical. That's all over 2. Now let's go ahead and reduce this as much as possible. So I know that 4 divides into 12, and I can take the square root of 4. So this becomes negative 2 plus or minus the square root of 4 times 3. The square root of 4 is 2, so this becomes negative 2 plus or minus 2 radical 3, because 3 is left over inside the radical. Then when I divide all this stuff out by 2, I get, let's see, negative 2 divided by 2 is negative 1 plus or minus, and then I have to divide this by 2 as well. So the 2's just cancel out, and I get square root of 3. And this is the irrational number that I was talking about. Those are our other 2 zeros, believe it or not. So one of our zeros is 2. One of our zeros is negative 2. One of our zeros is negative 1 plus the square root of 3. So negative 1 plus square root of 3, whatever that number is. And then negative 1 minus the square root of 3. So negative 1 minus square root of 3. So that's 1, 2, 3, 4 zeros, just like what we had predicted up over here. Okay, next, let's go ahead and list off the multiplicities for each of them. Since each 0 was only used once in the synthetic division algorithm to break it down into its factors, then that means that each of them is going to have a multiplicity of 1. And therefore, since all of these are odd multiplicities, each one of them are going to cross through the axis when we get to those x-intercepts. And we could have assumed that as well, just based off of the graph. See, it passes directly through the axis for each one of these zeros. All right, so that's going to be helpful when we graph those points out. Now let's get the y-intercept. To get the y-intercept, I just plug in 0 for x, and I get 0 plus 0 plus 0 plus 0 plus 8, which is just 8. Okay, so let's graph a couple of these points. And, oh, wait, I just remember we got to leave this in terms of a factored form. So we have zeros of -2, 2, and then we have this these irrational numbers. Now, if we trace it back through the irrational numbers, we actually started with this quadratic. We call this a prime quadratic or an irreducible quadratic, so we can leave that as one of our factors if we choose. So one of my factors is 2, so I get, one of my zeros is 2, so I get the factor x minus 2. Another one of my zeros is -2, so I get the factor x plus 2. And then my last factor is this irreducible quadratic, which is going to be x squared plus 2x minus 2. All right, now let's put all this stuff together and graph it out. 0, 8 is our y-intercept, so we go over to 0 and then up to 8. There we go. We have x-intercepts at 2 and -2, so that's going to be here and here. And then let's figure out what that -1 plus square root of 3 is, because we're not going to be able to get an exact value for that, but let's see what we can estimate it to be. So -1 plus the square root of 3. So that's like, 0.7 something. So it's going to be like, I don't know, right around there. It's going to be before 1, so like right there. And then let's try the other one out. So -1 minus the square root of 3. And we get -2.73 something or another. So it's going to be to the left of -2. Maybe I'm going to try and draw that a little bit over closer to here, a smaller dot. And then -2.73, which would be like right over there, somewhere right over there. Okay, so our end behavior starts by pointing up on the left, up on the right. So the graph starts by pointing upwards, then it heads over towards that first asymptote right there, or not asymptote, sorry, that's rational functions, towards that first x-intercept right there, passes directly through because it's going to cross directly through all of those intercepts. Then it's going to make its way back over to this intercept and cross through. It's going to make its way up to this y-intercept at some point and pass through. And then it's going to head straight back down over to this intercept down here. It's going to pass through that, turn around, go to that x-intercept, pass through that, and then continue on its way towards pointing upwards as our end behavior states. So to be perfectly honest with you, I think that this one is on par with the level of difficulty on the test, except for one thing. We probably wouldn't have irrational zeros, not in this class. We'd mostly have rational zeros like even integer values. So look forward to those ones. Nothing too nasty with the quadratic formula or anything. So that completes the second problem. If you have some questions, please make sure that you come by in the morning and get some help. So that ought to be it. Good luck studying, and if you need a little bit of extra help, you can send me an email or whatever. All right, that's it. Bye-bye.